Welcome to the course Prestress Concrete Structures. Our today topic is load balancing method. First, we will study a concept, a basic concept of load balancing method. So here, uh, let's read a concept. The method uses the vertical force generated by the draft or Hall pre-stressing tendons to counteract the downward load acting on the beam. The tendons are placed in a curved parabolic profile within the concrete beam. This profile creates an upward force when tensioned. The upward force from the tendons is designed to balance or reduce the effect of gravity loads, dead or live, on the beam, minimizing the bending moments and deflection. This is the basic concept of load balancing method. Here in load balancing distribution loads and parabolic tendon profile, you can clearly see that how a tendon is profiled as its distributed load is balancing the external gravity load. So here you can see clearly that this parabolic profile is resisting that or balancing that imposed dead load or live load. So we draft our tendon. The tendon follows a parabolic path, creating a more evenly distributed upward force along the beam's length. This profile effectively counteracts the uniformly distributed load acting on the beam. This uniformly distributed load is external gravity load, which is balanced by the vertical distributed forces from the tendon profile created by the tendon profile parabolically, which the profile is parabolic. Okay, let's talk about balancing using parabolic tendon profile. How this balancing occur? Parabolic tendon profile equation. The general equation of parabola can be written as here. This is the equation for the parabolic tendon profile. Let me highlight it. Let me highlight it for you. So y is equal to ax square plus bx plus c. Okay, this is basically the equation for the parabola. So we will generate a mathematical equation for load balancing method. So we started with an equation of parabola. So this is basically a parabolic profile having a distributed load q act on it. So let's point let's draw a 2 points, point A and point B. Point A is 0 0, means x is equal to 0 and y is equal to 0. This is the left support, and point B is the right support, and the third point, which should be a point C at midspan here, where I am. Let me highlight this point. It is not mentioned in the notes, but this point where x is equal to L by 2 and y is equal to A. This is a point. Let's suppose this is the region or a point where x is equal to L by 2 and y is equal to A. So let's move to the derivation. At support left, for x is equal to 0, we have y is equal to 0. Yes, definitely. At support left we have x equal to 0 and y equal to 0. Put these values in equation 1. Equation 1 is basically this parabolic equation. So putting values, we get c is equal to 0. If we take the first derivative of the equation with respect to x, the equation becomes this. And now again put the values, so we get b is equal to 0. So c is equal to 0 and b is equal to 0. So let's move to the next point at midspan. At midspan, x is equal to L by 2, y is equal to a. Yes, definitely in the diagram or in the figure, you clearly see that y is equal to L by x is equal to L by 2 and y is equal to a. This is a. This is a vertical y at this point y is equal to a and x is equal to L by 2. So let's move further into the derivation. So by putting these values in the equation 1, we get a is equal to a into L by 2 whole square plus b into L by 2 plus c. We already got b and c are 0. So by putting b and c 0, we get this. We get this a is equal to al square by 4. Uh, so we got the value for the greater a is equal to 4a by L square. So here from calculus the load intensity Q is equal to T double derivative of y with respect to x. Let's find double derivative of y. So here is the equation, parabolic equation. Let's derive it first. First derivative, and here it's the second derivative. It's a basic mathematics, you guys can clearly understand the steps. So finally we got the double derivative and we put it back in the equation 2. We call this load intensity equation an equation 2. So by putting the value in equation 2, we got this. Q is equal to 8ta L square. We got this. So A is the eccentricity of the tandem at center. So we can write it Ta is equal to QL square by 8. Okay, we got this. This is actually the balancing force or vertical force which is balancing that external gravity loads. So hence if the tandem has a parabolic profile in the pre-stress beam, the pre-stressing is denoted by P. So here a pre-stressing force which is in the pre-stress beam, that is resisting actually that external gravity load. From the above derivation, we clearly see that the two sets of equal and opposite transfer loads WB cancel each other and no bending stress is produced. Here in the diagram, you guys clearly see that this WB is from the external gravity load and this WB is from the resulting from the load balancing of a pre-stress beam. So as there is no bending, the beam remains straight. As these WB and this WB are same, are balancing each other, so definitely the beam will be straight without having a convex shape or a camber at the top. So when the beam is straight, there will be a uniform stresses. Minus PA minus P prime by A. This when these two loads cancel each other, so there will be uniform stress. Let's move further. The concrete fiber stresses across the depth of the section at midspan becomes Ft is equal to minus P prime by A, and Fp is equal to minus P prime by A. These are the uniform stresses where P prime is equal to P cos theta. Yes, definitely, as in reality, we say that this is the force is like this. Let me draw it in a black color. The force is like this along the line of action of tendon, and there is a theta angle. So this is p is equal to cos theta component of that p. This is the p cos theta. So this p cos theta is actually introducing that uniform stresses. Okay, let's move further. How we get these net stresses are uniform stresses. In reality, this whole process is done in the load balancing method. Imposed dead load stresses and balanced load stresses are balancing each other, so they cancel each other, and we got these net stresses. Note that the pre-stressing force in the load balancing method has to act at the center of gravity of the support section in simply supported beams in order to prevent an eccentric unbalancing moment. Definitely, yes, we have to apply the pre-stressing force along the CGC line to prevent the eccentric unbalancing moment. We don't want want eccentric movements, so we have to apply the pre-stressing force along the CGC line. Let's move to a condition. A condition says when the imposed load exceeds the balancing load. Yes, it's maybe the case. It's maybe the case, or sometimes it is the case. So when the imposed load exceeds the balancing load WB such that an additional unbalanced load WUB is applied. So in the numerical problem we will further explain this condition with a clear concept. Here just you have to understand that when the imposed load exceeds the balancing load, so we have to introduce unbalanced load. So due to this unbalanced load, we have to calculate the unbalanced moment, and that unbalanced moment have to be considered in the equation of finding the pre-stresses at extreme fiber at mid-span. So in the stress computing equations, we have to consider this MUP unbalanced moment. So these are the final equations, and definitely yes, these equations will yield the same values of fiber stresses as from the basic concept and C-line method. So we will further explain the concept in this numerical problem. So this is the numerical, and the given data is in the book page 42. Book name is Pre-Stress Concrete by Navy. So comment me if you guys want a book. I will just upload that book in the description. So let's move to the solution. So first of all, that effective pre-stress is P prime, or we already discussed this effective pre-stressing force in the previous method, in the C-line method and in the basic concept method. So at mid-span, A is equal to EC, and EC is equal to 14.77. Eccentricity, this is eccentricity at mid-span. We have to use eccentricity of mid-span as A. In the diagrams, you clearly see that A is the midspan eccentricity. So first of all, we have to calculate the balancing load. So balancing load equation is 8PA divided by L square. So we have the P, we have A, and we have L. So all these values we have. So we just put it in the equation and we got a balancing load WB. So here is the concept now of load balancing method. Note if the gravity load is equal to 552 PLF, then there will be no bending stresses. The beam remains straight. Only the uniform stresses will act. Yes, definitely. If this is actually the balancing load that is from the tandem profile, and if the external gravity load is also same like 552 PLF, then there will be no camber effect. There will be no convex shape or concave shape of a building of a beam. So there will be a just the beam will remain straight. Only the uniform stress will act. If a beam had a parabolically draped tandem with no eccentricity at support, this is because the gravity load is balanced by the tandem at midspan. This is the load balancing concept. But in our this example, we have total load that is actually 779, which is not equal to the 552 PLF. So we have to find the unbalanced load. So unbalanced load is calculated 779 minus 552. So unbalanced load is calculated, and from unbalanced load we calculated unbalanced moment, as we need unbalanced moment in our equations. So we have to use equation A in equation B that we previously derived in load balancing method. So just put the values, we will got the fiber stresses at top, extreme fiber stresses at top, that is in compression, and extreme bottom stresses at midspan that are in tension. Yes, definitely bottom will be in tension. So we have to apply a check for maximum allowable tensile stress in the concrete. So FT, the allowable tensile stresses in the concrete are given, that is 930, and in our beam we have tensile stresses 594. So we are uh, in a safe zone. So we can say it's okay. Uh, so here this is the example of load balancing method. So if anything that is not clear to you, just mention in the comment box. I will answer that. Thank you for listening.